We'll proceed in vector algebra and calculus. Vector algebra and calculus. We are in a phase of calculating work done. Calculating work done. Work done in a way, work done in a way Work done in a way force into displacement is the work done. I believe this is well explained in the last video. Force into displacement is work done. If this is the force, if this is the force and displacement has to happen along this line. If this is the force and displacement happens to be on this line, what is the work done? Better way. Consider that there is a wind. There is a wind that is going in this. This is origin. This is origin. This is x-axis. This is y-axis. This is x-axis. This is y-axis. 90 degree. Now one one vehicle one vehicle is standing here, and there is a wind that is passing like this in this direction. Then this vehicle, because of the wind, this vehicle would move. Okay, then if it moves if it moves, then how much is the force? If this wind has some force, how much is the force that vehicle is feeling in this direction? F cos theta. F cos theta means if this is the force, then F cos theta will be less amount than F. That much is the force that is being felt in x-axis. If that is the case, then F cos theta, and if vehicle moves by x distance because of this wind, then F cos theta x is the work done on the vehicle. That is the work done on the vehicle. Make sense? Or consider vehicle is moving in this direction. Okay, vehicle is moving in this direction, and it is doing some work, and then because of the wind, this now vehicle is moving from here to here. Because of the wind, vehicle is getting some force from the vehicle is getting force from the wind also. So, what is the contribution of the wind? What is the contribution of the wind as far as vehicle moved from zero to x? If vehicle moves from 0 to x, vehicle is doing work. Okay, vehicle is doing work. What is the comp work? What is the energy it is receiving? Better way. What is the energy it received from the wind when there is a energy that is vehicle is getting because of the fuel? So whatever energy it is getting because of the fuel, if there is no wind and vehicle from moves from here to x, then how much is energy dissipated by the fuel? If wind is like this, then vehicle is moving from here to x, then will it same energy the engine is dissipating? Certainly not. In that case, the energy burnt by the fuel would be less because it is getting energy from the wind also. How much it is getting? Okay, that is F cos theta into x. Whatever is this, that much energy it is receiving from the wind. Okay, so now we learned that F cos theta, and this better to say what is the vector for the F. What is the vector for the x? I can say this is I plus j. I can say this is I plus j. If I say the wind direction is this is y axis, this is x axis. Okay, or someone can say this is east and this is north. Then wind is flowing north east 45 degree. Then the equation, then the equation of this line is I plus j. What is the power of the force? I plus j. I plus j divided by square root of 2 is the direction of the wind. Power is the square root of 2. 1 square plus 1 square, square root. Okay, if that is the case and vehicle is moving 0 to x, how much the energy vehicle is receiving from this force? I plus j, I plus j dot I direction. I plus j dot I direction. If I say like that, then I plus j dot product of I is 1. That is the work done. That is the work done when vehicle moves 1 unit. If it moves x unit into x. If someone cracks it, whatever I'm going to say, then the vector calculus is under his arms. Okay, so now he is now the work done is I plus j dot I direction. If someone says, then work done is 1. If it moves by 1 unit, if it moves by x unit, then it is x joule. Okay, Newton meter. That is the energy vehicle is receiving because of the wind. Okay, or someone can say f cos theta, f cos theta into x if it is moving x. Then what is f cos theta? F is the square root of 2. Magnitude of f is the square root of 2 into cos theta. Cos 45 degrees 1 by square root of 2. Gone. And now it is 1 into x. X is the energy it is receiving because of the wind. If wind is along this direction only, then f into x, more energy it is receiving from the wind. Otherwise, less energy it is receiving from the wind. If wind is in this direction and vehicle is moving because of the fuel, then it is wind is in this direction, vehicle is moving in this direction, then certainly it is not receiving any energy from the wind. Someone would say, how come you are not able to get any energy from the wind? A car is moving in each direction, and then car is moving in each direction, and wind is coming from south to north. Exactly. Now car is moving. Is it getting any energy? Is it getting any energy from the wind either in the direction of the movement or anti? There can be anti also. If car is moving like this and wind is exactly like this, then fuel burning will be more. Okay, to move the x distance. How much the fuel burning will be more is the F into x. That much energy it is against the car movement. But if it is 90 degree, then theoretically from the vector, the car has no difference. Car has no difference. It is exactly going like there was no wind at all. Okay, now that is the scenario. Very nice, right? Now, what is the wind? What is the wind? That is I plus j. And car movement is 0 to x along x axis. What about what about wind? Wind is xi plus xj. What is the direction of the wind when the equation of the vector is xi plus xj? Xi plus xj divided by x into a square root of 2. Same direction as it was I plus j. Same thing, right? Only thing, direction is same. Only thing, it difference is the magnitude. Earlier, the magnitude of the force, air, air, air force, air force, the magnitude of the air force by the square root of 2. Now, magnitude of the air force is x into a square root of 2. How much is the work energy this vehicle is receiving when it is moving 0 to x? Then xi plus xj multiplied by x dot xi. This is what more or less we did in last example. xi plus xj dot product with xi, or x into a square root of 2 magnitude cos theta into x, that is in force in direction of the x-axis. Then x into a square root of 2 cos theta, 1 by a square root of 2, a square root of 2 gone, x into x square is the work done. Absolutely wrong. Wrong. What happened? I just said x, right? Then if I say dot product also xi plus xj dot xi, x square is the energy received by the car when it is moving 0 to x. What is wrong going on here? If this is I plus j, if this is I plus j and car is moving in I direction 0 to x, then I can say the car vector, the displacement vector is xi. If it is 0 to x, we are calculating the energy, then it is xi. This is what it will be called. And this is I plus j dot xi x. X is the work done. Through many ways we calculated x is the work done. But if this is xi plus xj, xi plus xj, I'm not saying yj, xi plus xj dot with xi, x square is the work done. Wrong. If someone really understands this, then he is master of calculus. What is the problem going on here? Certainly, work done is not x square. Then what is the work done? X square by 2. That is the work done. Why? Why? If I say the air vector is I plus j, then power of this air, now car is moving like this. Okay, car is moving in this direction. Now 0 to x. Now if I say this vector I plus j, then any point if I calculate, the magnitude is square root of 2. The power is the square root of 2. That is constant. Everywhere it is constant. But means force, force if I calculate at origin of the air, it is the square root of 2. If I calculate the force here, then it is the square root of 2. If I calculate the force here, it is the square root of 2. Same, right? Now we have xi plus xj. If I calculate here, it is x into a square root of 2. If I calculate here, it is also x into a square root of 2. If I calculate here, it is again x into a square root of 2. Same thing, right? That's why I say 99% of mathematics is numerical mathematics. In 1% only algebra, different coordinate system, spherical, this and that, and then calculus and then vector comes. 99% of mathematics or more than that is numeric mathematics. If someone is not master in numeric mathematics, he cannot learn anything in mathematics. Now, anyone would say, I don't care your x, y, z. What is the magnitude of the air? You tell me at the origin. That is x into square root 2. What is x here? That is 0. Force air, there is no air at all here. There is no air at all here, or air does not have any force. But as we go along x, then whatever this point has the x, that much force of the air is growing as we grow along the x-axis. Can you see it? If x is 5, at this point the force of the air is 5 into a square root of 2. Here it is 3 into a square root of 2. Here it is 1 into a square root of 2. Here there is no force. But in earlier case it was a square root of 2 constant all along. A square root of 2 cos theta, and then how much displacement it made. That came at x only. But here it is varying. If 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 I am multiplying two items, force into displacement is nothing but multiplication of two items. When multiplication of two items comes in, then integral calculus comes in. Whenever multiplication of two items comes in, then integral calculus comes in. Integral calculus say that multiplication of two items is nothing but there is a rectangle whose one multiplication of two items, item 1 into item 2. that is equivalent to one rectangular region where one side is item 1 and another side is item 2. If you calculate the area, that is a multiplication. Someone would say calculating the area is multiplication only, right? Item 1 into item 2. No. Calculation of any shape's area is certainly not multiplication. Many times I have said take one square of width 1 and height 1. Now place in the rectangle. Now count it how many there. That is the area, whatever it is. So if I have multiplication of two items, that is nothing but area of a rectangle where these two items form the two sides of the rectangle. If it is really a rectangle, then there is no problem. We can go with simple multiplication. But if it is not a rectangle, then we have to go with the abstract multiplication, not the direct multiplication. Like if it is now force, forget the force. Now this is x-axis and force is xi plus xj. Xj has no importance when I do dot product. X into x we are doing. What is x? One x is x direction and one x, that is force 1, that is function over x axis, that is x. That line, if I draw a simple curve, simple graph, that line will make a triangle. X into x multiplication of any two item can be calculated by calculating the area underneath it. X into 3, if this is x into 3 means 3 is the height. In that case, whatever is the area coming, that is what you are trying to calculate. X into x. What is constant between these two is you are calculating the multiplication by calculating the area. If I say x into x, one is independent component x and one is dependent component x. One is called x and one is called y. Actually, you are multiplying x into y or x into fx. That is the problem. So, if this is x, then this is the y, that is varying, or f function over x, so that it forms a triangle. What is the area? X into x, wrong. X into dx. This is called abstract multiplication. Now, these two sides can be anything. I just can say width into height is the area. Width into height or height into width. If this is the width x, independent into dependent is the area. Independent into dependent is the area, because this is abstract, right? This is not the concrete one we are thinking. Then what is the area of this triangle? If this is x, right? Because it is growing the way x is growing. If it is like this, then it is x, and then this is a constant. A flat line will come like this. That is one typical height will be there, but here height is different. Okay, what is sin x? If it is sin x, if it is sin x, then if this is x axis, then this is the sin x curve. This is the sinus curve over the x axis. One is below the x axis. This is changing. So y equal to fx equal to sin x. Here y equal to fx equal to x. Then what is the multiplication of x into fx? Is not directly x square. It is the area. So I can say that integral calculus which calculates the multiplication by calculating the area or addition. At the end we are calculating addition only. Calculation of the addition by calculating the area is the complete multiplication. Normal multiplication is not the complete multiplication. Normal multiplication works only when both the items in multiplication, both the operand in multiplication are constant, or at least one of them is constant. Then only normal multiplication works. If both are variable, where one is independent and one is dependent, then normal multiplication will not work. In that sense, we go by calculation of area to get the multiplication. That works for the normal multiplication also, that works for dependent and independent component also. Calculating the multiplication through area is integral calculus. Very simple. Now, if that is the case, then it is triangle, and triangle area is if this height is whatever it is. If this is x, then height is x. Then this forms a rectangle and area is x square. If this is half, then x square by 2. Makes sense? So work done by a force, work done by a force whose direction is xi plus xj, xi plus xj to a car that is moving along x-axis from 0 to x is xi plus xj dot xi. Not true. Not true. Because if I do like it becomes x square. Then this xi along which we are calculating the multiplication, that is independent component, there I have to place d. I have to place d. Then it is force dot dxi. Now it becomes x dx, x square by 2. Now this dx, now consider I am calculating the work done from 0 to k. 0 to k is a point here. Now in that case 0 to k, then how it would be? I was trying to calculate 0 to x, 0 to x. Then we did xi plus xj dot. Instead of saying xi, I placed d there because this is not normal multiplication because force is dependent upon x-axis. If that is the case, then it is force dot dxi. Now it becomes x dx. xi plus xj dot dxi becomes x dx, x square by 2. Now consider I want distance from 0 to k, 0 to k, then how it would be? Not 0 to x. Then whatever the independent component is, whatever the independent now if I say 0 to k, 0 to k, then it will be x, xi plus xj, xi plus xj dot I vector, whatever comes multiplied by k, because for k amount I want complex, right? Then where the dx gone? So now here the generic notation comes into the picture. So what generic notation says that if you want to calculate, this is called also called line integral, knowingly, unknowingly. This is also called line integral. Loosely, this is also called kind of, if I take reverse way, then directional derivative along a axis. That is in differentiation. In integral, same thing is called line integral. Integration of this vector along a line. So line is I vector. Line is I vector. Line is I vector. Okay, and the vector for which I want integration, now it came to full-fledged integration, that is force vector. Then force dot d of what? Because I want 0 to k, 0 to k along x-axis. Then it says that take any point on the line where you want to calculate the line integral. Consider this is any point that is x comma y. Then vector equation for the x comma y here is xi plus yj. Xi plus yj. Knowingly, unknowingly, you are trying to calculate the multiplication of this force along a line that is xi plus yj. We will move on it. It's not that simple. Then it is force dot xi plus yj. Place d there. Then force dot d of xi plus yj. Now here on this line everywhere y is 0. Now it is force dot dxi, integration from 0 to k. Okay, now it is simple. Okay, I believe it is all right. Now let's consider Okay, this is x-axis and this is a circle. This is a circle. Okay, and this is the wind. Wind is xi plus xj. What about if I say wind is xi plus yj? Question arises, what if I say wind is xi plus yj? How the wind would be? When I am along the x-axis, the wind is exactly in this direction because y is 0. If I talk about y-axis, then x is 0. The wind is exactly like this. Wind direction is changing, wind magnitude is changing, xi plus yj. If I say I have a point here 1 comma 1, then xi plus yj, then I plus j. Wind is flowing in this direction. At this point, wind is flowing in this direction. At this point, wind is flowing in this direction. At this point, wind is flowing in this direction. Depends upon the point, xi plus yj keep on changing. That is the wind direction, that is the force direction. Now, now consider my car is rotating. This is anyway, I don't have any car over. Okay, so consider my car or some car is rotating on a circle. The car is rotating on a circle. Car is rotating on a circle. Consider there is no gravitational pull. Car is rotating on a circle because of its fuel only. So it is going like this. If wind is flowing like this, then how much energy this car is seeing when he is traveling. Now this is x-axis. Consider, consider this is x-axis. This is x-axis. This is origin. This is origin. This is y-axis. And wind is flowing like xi plus xj. Now if car is moving from here, this is why I said there is no problem with the Earth gravitational pull. Consider this is x-axis and y-axis; they are on the ground. Now it makes sense. Car is moving in a circle. Now I kind of little bit rotated it. Now this is x-axis and this is y-axis. Car is moving in a circular fashion. If that is the case, wind is flowing xi plus xj. If his car is moving from here till here, from 0 to k, from 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 0, this is the 0. From 0 to k distance, car is moving in a circular fashion, whose x-axis is 0 to k. If that is the case, then how much energy car has received because of the wind? Then someone would say that what is the vector of the car? If car was moving on x-axis, then vector of the car was xi plus xj because xi, not xi plus yj. Y is 0 constant. It is xi. The vector what we say, it is I. Actually it is I. But in vector form, I said it is because I have to multiply force with displacement. So force is capital F dot, just I cannot say di. There I have to place x there, dxi. So I consider it is xi. Similar to that, if I take any point here and this is the origin, if I connect, then this is xi plus yj. This point is x comma y. Point is x comma y. Then if I connect from origin, this line is xi plus yj. If that is the case, and this is the force, that is xi plus xj, look like they are in same direction, but not true. Car is moving in this direction. And if I take position vector is radial to the car movement. What is the vector that in which car is moving? That is important. If car is moving in a circular fashion, I need tangential vector at each moment. That is also called curve vector. That vector will be get dot product with the force. That vector will have dot product with the force. Then only I get the work done of the car along this curve because of the force. Force is xi plus xj. Then what is the vector equation that is along this curve. How to calculate it? I believe I can give it for assignment that how I can proceed on it. If displacement is along a curve and force is any vector that is varying, if I say force is xi plus xj, if I say force is xi plus yj, whatever it is. Now displacement direction, it can be a static vector, that is I vector. It can be I plus j vector, that is again a static vector in a straight line. Or the path can be a straight line. If it is a straight line, then it is a static vector. But if it is not a straight line, then vector what I need to take, it will be algebraic vector. It would vary at every point. The way force is varying at every point, direction of the force, xi plus yj. If I take xi plus y, we will take both xi plus xj and xi plus yj. Both we will take. Now, in that case, the displacement is not along a straight line, it is along a curve line. If displacement is along curve line, the curve vector, if this is curve and displacement is happening in the curve, then curve vector at each point is different. Means this is algebraic curve. This is algebraic curve vector. The vector has x component and y component, and these components are variable. They are not constant. If it is constant, then it is a straight line everywhere. But if it is a circular region, then this curve vector is tangential, it would vary everywhere. If it is varying at each moment of x and y, this is called vector field, algebraic vector. In that sense, how we can go with the line integral along this line? Okay, so that we would proceed upon. I could have finished, this was the idea, but this is an assignment. Please do support us. +91 is the India country code, 9483160610 is the telephone number. 9483160610 is the telephone number, +91 is the India country code. Okay, someone can comment it with the solution that how I can proceed with this kind of line integral.